A high-energy sound beam shattering a kidney stone, a radio dish capturing whispers from deep space, the towering concrete shell of an industrial power plant. These systems are governed by the same algebra equations typically found on a standard high school worksheet. In class, we memorize formulas to find vertices and foci, but we rarely connect these strings of numbers to the physical systems they define. Every one of these shapes is generated by a single geometric action, slicing a three-dimensional cone with a two-dimensional flat plane. If that slice is perfectly horizontal, it produces a circle. This is the most basic conic section. Tilting this plane alters the mathematical rules of the intersection, changing how the resulting curve directs light, sound, and gravity. As the plane tilts, the circle elongates into an ellipse. This shape possesses an equal angle property. Within the ellipse are two fixed points called foci. Any wave emitted from one focus will bounce off the curved boundary and hit the second focus at the exact same angle. Medicine utilizes this property for lithotripsy. By placing a wave emitter at one focus and the patient's kidney stone at the other, high-energy sound waves reflect off the chamber walls and converge to break the stone apart without damaging the surrounding tissue. This geometry also governs the solar system. Planetary orbits are elliptical, with the sun positioned at one of the focal points rather than the center. Historically, illustrators have struggled with this concept. In this portrait of Isaac Newton, the background diagram incorrectly places the sun at the center of the orbital rings. The ellipse serves as the geometry of the closed system, providing a predictable path for planetary motion and the containment of energy. If the plane continues to tilt until it is perfectly parallel to the slope of the cone, the curve breaks open into a parabola. Mathematically, a parabola is an ellipse where the second focus point has been pushed out to infinity. With only one local focus remaining, the parabola acts as a flawless receiver. Parallel waves arriving from deep space enter the curve and reflect inward to hit that single focal point. Satellite dishes use this curvature to gather weak radio signals and funnel them into a central receiver. This geometric property also works in reverse. Placing a light bulb at the focus of a parabolic mirror projects light forward in a perfectly parallel beam, as seen in vintage car headlights. This shape is a natural consequence of physics. A jet of water or a thrown stone will follow this exact path as gravity pulls it toward the Earth. The parabola connects the infinite reach of parallel waves to a single, localized point. A vertical slice through two stacked cones creates the final section, the hyperbola. When we rotate these curves around their vertical axis, we create a three-dimensional shape known as a hyperboloid. This geometry is the standard for large industrial towers. The flared top and narrow waist help manage airflow efficiently. Though the tower appears curved, it is a ruled surface. This means it can be constructed entirely using a lattice of straight beams, making it incredibly strong and efficient to build. Hyperbolas even describe human behavior. The economic demand curve, where lowering a price increases the quantity of goods sold, often follows a hyperbolic path. This geometry provides the structural integrity and flow necessary to manage everything from thermal air currents to global markets. Slicing the cone gives us a circle, then an ellipse, a parabola, and finally a hyperbola, morphing the math as the angle changes. Those classroom equations are the instructions allowing us to heal the body, communicate across space, and build our most massive structures. Ancient Greeks studied these curves for the pure joy of geometry, unaware that their work would eventually provide the mathematical foundation for modern engineering. Standard textbook equations describe the foundational logic of our modern world, tools that allow us to build the future.